Okay, all right, today we're gonna look at a couple of special case equations. Going to start out the same. We still got variables on both sides, so we're going to follow a very similar routine that we did on Monday. We are still looking for distribution first, and we have distribution. Negative 4 times 2x, negative 8x. Negative 4 times positive 1, negative 4, equals, right side's going to stay the same. Recording a lesson. Okay, so distribution is done. Both sides are as simple as they're going to get. So there's nothing on either side that I can combine right now. Both sides are as simple as possible. Now it's going to come to moving the variables. Okay, I am going to move my variables to the left-hand side. So I am going to choose to add 8x to both sides. Now in doing this, okay, I want you to notice what happens here. Negative 8x plus 8x on the right side disappears. There are no more x's. On the left side, negative 8x plus 8x also disappears. This is hence the special case today, okay? The very thing that you were trying to solve for is now gone. There are no more variables left. So that kind of raises a little bit of a flag. That's how we know this is going to be a special case. At this point, we need to look at what we have left over. Variables have canceled. What I have left is just simply negative 4 equals negative 2. And I need to ask myself, is this a true or false statement? Is negative 4 equal to negative 2? And that statement is false. That statement is not true. Therefore, we get no solution here. Okay? So again, variables cancel out. I want to look at my leftover statement. If my leftover statement is false, then I have no solution. There is no possible number or numbers that I can put into this equation for x that will cause it to be true. But again, here's the key right here. Variables cancel out. That's kind of the big key to all this, okay? If the leftovers are false, no solution. Let's look at the next one here. Very similar type setup. There's my right and my left. We do have some distribution. On the left side, negative 5 minus 9x. On the right side, 3 times 1 is 3. 3 times negative 3x is negative 3x. And then we've got a minus 8. So there's what it looks like post-distribution. On the left side, cannot combine anything. Negative 5 minus 9x, both terms are unlike, cannot combine those. On the right side, we should be able to collect the 3 and the minus 8. Left side stays the same. 3 minus 8 is negative 5. And we also have minus 3x. So now both sides are as simple as they're going to be. And I have a mistake here. Let me back up here. My mistake here. Boom, there we go. Guys, that should be a minus 9. That should be a minus 9. My mistake, my fault. That should be a minus 9. There you go. Even sometimes I overlook it. So make sure you get that distribution done, even for myself. So that should be a minus 9 there. Now, if we take a look right here, look at my variables. Identical variables on both sides of an equation will cancel out. It doesn't matter which side I try to move the negative 9x to, I would have to not add 9x in order to do that. And look what happens. They cancel completely out. So again, your variables cancel completely out, which kind of raises a flag, and that kind of alerts us that we've got a special case. Look at these leftovers here. That's all we have left. Negative 5 equals negative 5. And that is a true statement. Negative 5 equals negative 5. This is a true statement. Therefore, infinitely many solutions. Okay? Infinitely many solutions. All right? So again, the big characteristic here of these equations that we've looked at is that your variable term, your variables are canceling completely out, which raises a flag. We want to look at the leftovers. Okay, if the leftovers are true, infinitely many solutions. Okay, so that's why that's a special case today. And then we're just doing on the third page of that assignment that was in there on Monday, which you'll see again today, we're just doing problems 1 through 4. Okay.